each of you to spend some time asking them questions. I've done a lot of talking, but they know a lot more than me about different parts of this robot. So ask about different things on here. You've spent time taking things apart, and you kind of know maybe like, these are wires or these are motors. Like, what are they going to? Why are they there? What do they do?
Why are there so many wires?
And why is this thing one of the most complicated things that we've had to deal with this year? This is the first time we've ever had wires that had to move.
Because this has each one of these could turn at any time.
Yeah.
Because it's stuck.
All the wires could make
You have no idea how complicated it was this year to make wires go up and down. The fact that we had motors on something that moved, it's the first time we've ever had to do that. We've never had something powered on a moving thing. And so that was really hard.
Yeah, and like last year's robot, we had anything that's moving that's actually done remotely. Like nothing moved relative to the frame, but the piece that moved didn't have anything that moved on it, except for like one airline that we had to deal with. So that's why this robot is such a new experience for us, because we never had to move 3 or 4 motors plus cameras plus sensors on a piece that goes up 6 feet.
You might have said this already, but like how long did it take from day 1 to finish this?
We have a build period. So once the game is released, we only have 6 weeks to build a functioning robot for the game. So, but once we reach our competition, we're able to make minor some adjustments as long as we're not putting our robot overweight.
One thing that was really hard this year is because everything was so complicated, every design team needed a lot more time than we needed last year. And so when people were designing things this year, they had to work on it for an extra week or 2, and we didn't get to put all the pieces together until about a week and a half before our time was up. And the first time that we got everything put together, you know how much this thing weighed?
305.
Not quite that big.
This robot now weighs roughly 120 pounds, right?
120 pounds is the limit.
Wow, that's 120 pounds. That's it. I mean,
heavy.
in
That's
some
about
ways that
batteries
seems
and
light.
bumpers.
That's like as bad as a human.
Yeah. A lot of you guys might be close to that.
And how many different, you said you had different design teams working on different components. How many different design teams were there?
So we had a team that was working on building this box part here. We called it the box. Nice name for it. We actually had a different team working on the arms that go on the front here. They didn't used to go on the front. They used to actually mount down here as a separate thing. But in order to have a separate motor for them, it weighed too much. And that was one of the things we had to take off and then come up with a new plan. So we had a group on the box, a group on these front wheels. We had, what else we had?
We had the lift.
Yes, we had a coding team that was very busy.
We had the lift team.
This lifter,
Electronics team.
electronics boards, there's a lot of wiring this year. This base here, this metal frame on the bottom, one of the things they totally redesigned it so that at competition, if we needed to fix a wheel or change out something here, these wheels pop right off. In the past, if we wanted to change something on our wheels, we used to have to take probably 45 minutes with working as fast as we could. It'd take at least 45 minutes to get in and get out from a wheel. And between matches, we didn't have that much time. So they redesigned the whole base so that it was faster to take apart and put back together. And so just like something like that, like how fast can you fix things that are broken? How easy can you get to things? That was a whole design team by itself of like 4 people working pretty much nonstop the entire season.
And one of the things that we're starting to look into is that we've learned from our experiences with the taking an extra week to design everything that's bad because we need time to build the test. So our drive team's been around doing nothing this year. So in this coming season over the summer, we're working so that we can make a computer, a big old server, sit there and emulate, like basically put this robot into a video game, like into a game that we can drive our robot around. Let's say it drives terribly. We can have our CAD team, people sitting on computers designing every piece on a computer. We can have them completely redesign a robot in 45 minutes in the less than 45 minutes, have an entirely new robot running in that computer, so that our drive team and our coding team can test the robot on the computer before they even have a real robot, which will help eliminate bad design choices from day one, like these ARM pieces that may have never been built, which they did get built, may have never been built if we did it in that virtual simulation. So we're going to try building and simulating a robot in a computer.
Another thing to consider is all the small tweaks that a lot of students had to do as we built it. So one of the rules is these wheels stick out beyond our frame, and we weren't allowed to do that by the rules. But you're allowed to have them stick out during the match, but you can't have them stick out before you start. So they had to come up with a way to make it so that they would fold back and stay tucked in the frame before the match started, and then when the match started, it would lift up and deploy. But that was something we didn't figure out until a few days, like 2 days before we left.
We did during our week 0 competition, like the competition we do like the week before we're done. So that last 5 days, we do it on like day 6 before our last 5 days. We were on the bus, we're talking like, how can we fix this problem that we ran into? And we came up with this on a notepad on a school bus driving home from the middle of our competition. Yeah.
And even little things like, what happens if one of these motors breaks and we need to change it out?
I know how that goes.
We have a pit crew that knows exactly what to do.
Masters at Versaplanetary.
And pulling apart gearboxes. But one thing that's cool is if you notice these plugs, we don't even think about it anymore. These plugs here, if you take this tape off, there's a little thing, and this cable comes right apart. That was something that we added ourselves because if we wanted to change a motor in the middle of competition, we didn't want to rip it out and take a hot soldering iron and melt off the wires and put another one on. We wanted to go boom, 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 and have it work just like that. And so we set up all of our systems so that it's really easy to change things out. So it's not just building a robot, but it's making it so that it's easy to fix, easy to repair, easy to change. All of those things can be really challenging. And we've learned every year. Our first year competition, we were terrible. Our second year competition, we thought we were going to be good, took 59th out of 60, and that was because one team got disqualified. We were really, I forget, it was something technical, like something that ended up being kind of like a safety hazard, so they got kicked out. But like, yeah, so in the end, like, we were really bad. It took us 2 years just to get something that like we can compete with, but the next year we went to state. So it was like, whoa, cool, that was really neat. And then the next year, we tried to get real fancy, and we got stuck on things, and we thought we had a cool robot, and it just, we didn't end up advancing. We did okay, we made it to the playoffs, but we just didn't advance.
We have about 2 minutes left, so I just want to, anybody have any questions? I have one more question, but if anybody else want to have a question? Yeah, go ahead.
Could you make the box go in and shoot?
And we'll do that.
Oh, we can do one quick shooting demo now that it's rewound. Here, I'll just preload it so you don't have to go down.
And then my question is, if there are kids that are interested in this, what kinds of, okay, listen up. If there are kids that are interested in this, what kinds of things can they be doing now to help them prepare to be ready to do this when they get to high school?
Yeah, one idea.
Lego Robotics.
Lego Robotics is a very cool one to start learning stuff. What else?
Can you guys think of anything else that might help you with this, if this is something you think might interest you?
What else would some of you guys recommend as far as things that helped you learn about making stuff?
Well, as you get older, some